All right, every time is an adventure looking to find how to build the rectangles for how we're going to find the volume. So here's e to the negative x equals 0, you know, is this, to make sure we get the graphs correct. X equal 2 is this, and y equals 0 is here. All right, so this is the area that's bounded, and we're revolving it around the y-axis. So if I try and draw rectangles perpendicular to the axis of rotation, I would have rectangles that would touch different top functions. So that is not a good choice. So let's not do those. And instead, let's draw rectangles that are parallel to the axis of rotation. So parallel gives me a shell. So I want to do volume is equal to 2 pi. Radius will be x, so x. And then height of the rectangle will be e to the negative x dx. And I'm going to build rectangles from x equals 0 to x equal 2. All right. Let's look at this next one, y equal root x. Then y equals 0. You know it's like this. And then y equal 2 minus x is this. Okay, so be careful that you look at the area that's contained between all three of the graphs. So that's this area here. Okay, so I'm revolving it about the x-axis. This is center line. So if I tried to draw rectangles perpendicular to the axis of rotation, like this, then they would have different top functions, and that is not good. You'd have to separate, do a lot of extra work. So let's not do that. So instead, I'm going to x-axis back in here. All right, so instead, let's build rectangles that are parallel to the axis of rotation. Parallel to the axis of rotation gives me a shell. So I can see that the thickness of my rectangle that I've drawn is dy. So dy integration. So it's 2 pi radius height times thickness. So the radius of this shell is going to be y, the distance from the x-axis. Then the height of the shell, so the height of the shell, you know how to find the height of a rectangle. So it's going to be the top minus the bottom. So it'll be the line subtract the parabola. So the line, I want to solve this for x equals. So if I take y equal 2 minus x and solve for x, I get x equal 2 minus y. So that's the top, 2 minus y. And then I want to subtract off this, which is y squared. And then where am I finding the building the rectangles from and to on the y-axis? I'm beginning at y equals 0, and I'm going to end where these two graphs equal each other. So x equal y squared and x equal 2 minus y equal each other. So good old quadratic solving. So I have y plus 2, 1 minus 1. So I see negative 2 and 1. So I can tell that this is the y value of 1, so 0 to 1. So where does this negative 2 come from? Well, if I was to draw the whole graph of x equal y squared, then this line would cross. Here's the 1. Down here would be the negative 2. That's just not in the area of what we're looking at. Just wanted to let you know where it came from. All right, y equal e to the negative x. Again, you know, looks like this. Y equal 1, you know, this crosses at 1, so there's the intersection point. And x equal 2. X equal 2 looks like this. X equal 2. Okay, so the area bounded is this, and I'm revolving it about the y-axis. All right. So we have a choice. We could build them rectangles sideways and do them perpendicular. I'd like to try and just practice my shells. So let's go do the dx integration. So dx integration 2 pi radius height dx. So from here, spinning this around, from here to here is x. Then the height of the rectangle will be top, subtract the bottom. So the top is y equal 1, subtract off the bottom, which is e to the negative x. And I'm building these rectangles from x equals 0 to x equals 2. All right, let's do one more here. Y equal x squared plus 2, x equals 0, and x equal 1, and then I have y equal x. So this is the area bounded, and I'm going to revolve it about the x-axis. So in this case, if I try drawing rectangles parallel, that's going to be different functions on the top and the bottom. So I don't want to do that. So I want to draw them perpendicular. Then they always have the same top function and always have the same bottom function. So when I'm doing the perpendicular, that means I'm doing volume by discs or washers. So I'm going to set up the framework. So it's going to be dx integration. So the outside radius will be the center to the outside. So that's x squared plus 2. And subtract off the inside, x. And then from 0 to 1.